Some of you might think, why does the repair or the restoring of a vintage devices take so much time, and why does it always seem to become so chaotic? You know, with a workbench strewn with parts, all unmounted parts and cut out parts and new parts and tools and all sorts of measuring equipment and you name it. It often gives the impression that you start with something quite orderly and rather quickly you end up to your ears in what seems to be complete chaos. Now, when that sets in, that chaos with everything unmounted and heaps of parts and tools and you name it, well, quite often that's the moment when panic sets in. And in my opinion, the best antidote against that panic is this. When you start to unmount stuff and open up stuff and all that, you should once in a while just take a time out and make an inventory of what you have lying about. Put a little bit of order in it, just clean up the mess a little bit so that it becomes more accessible again, and then just start working at the very last thing you wanted to do. So start working towards a very simple part, a small goal inside the device you want to repair. And once that is done, then return on your steps and then remount whatever it is you undid to reach your goal, etc. So retrace your steps up until the point when you say, okay, I retraced my steps, I mounted back all the other things that didn't need changing, or maybe under the way, every step you retrace, you change a few parts, and when you get back almost to the point where you actually started, then you start in a different direction. So to make it all clear, I'm trying to bring to life this IG-102 RF signal generator. Yeah, it's a Heathkit. Now, quite simply put, it doesn't output an RF signal. Why? I do not know. But instead of starting to unmount everything, I started with the very obvious things, like changing the electrolytic, which you see there, checking the tubes, which you see here, changing the original connectors for BNC connectors, and finally cleaning all the contacts with deoxide. Now, those are the simple, easy things you can do first. Obviously, one of the other things you can do is check for very obvious mistakes, like short circuits or loose wires or stuff like that. Always start with what is obvious. So never start unmounting parts and all that just like that. Start with obvious things and easy things first. So check for short circuits, check for circuit breaks, check for dirty contacts, and all that sort of stuff, you know, or a blown fuse, etc., etc. Oh, and by the way, I never understood this, but in a lot of vintage equipment and devices, you never ever seem to find a fuse. Now, it seems like the sensible thing to do to put a fuse into a device which is connected up to the mains, to a mains power outlet. I mean, it protects against short circuits, it protects against fire, it protects against, well, possibly, well, you could say explosions of stuff, and you name it. I mean, come on, a fuse, that doesn't cost the end of the world. A fuse costs maybe, I don't know, $50, and a fuse holder another $50. Let's say $2 for an expensive model. I mean, it's so obvious, and I never ever understood, and I never understand why they never did that. So as soon as possible, I'm going to buy a fuse holder and the correct fuse, and I'm going to mount one inside this RF generator, if only for the peace of mind. So anyway, like I said a few minutes ago, this RF generator is not outputting any sort of signal. So right now I'm doing the obvious thing, which is to check for obvious mistakes. Short circuits, circuit breaks, dirty contacts, you name it. So give me a bit more time, and I'll be back with an update. Okay. Well, I got some sort of signal out of the RF generator, and as you can see, the pilot light is on. Yeah, well, I can get some sort of signal out of it, but without a frequency counter, it's kind of hard to figure out what the frequency is that comes out of it. Now, it's set at the lowest range, which is between 100 kilohertz and 320 kilohertz. And well, if I turn the frequency setting, or rather the variable capacitor to change the frequency, nothing happens. As you can see, I can turn it all the way up, all the way down. Nothing changes. So the frequency just doesn't budge. It puts out a certain frequency, which I would suspect is, well, in the kilohertz range. I think. Let me see. Yeah, definitely in the kilohertz range. Because when I change the frequency, nothing really seems to happen. Nah, nothing happens. So it's definitely yeah, I think what I'm reading is a sort of a, well, I don't know. It's some sort of frequency, but don't ask me which frequency it is. I can roughly estimate which frequency it would be. Somewhere in the 100 range. Excuse me. So yeah, the output frequency is somewhere in the 100 hertz range, which is, as you can imagine, well, impossible, since it's in the 100 kilohertz range setting right now. Well, I mean, theoretically that's impossible. Practically speaking, it is possible, as you can see on the screen. So, well, yeah, what is happening? I don't know. It's definitely not good. Now, the weird thing is the tubes seem to work. They don't have shorts, and they measure out good on the tube tester. So whatever is the problem, it can't be the contacts, because I cleaned them. So it's possibly it's the tubes, or maybe it's one of the capacitors. So well, yeah, I have to keep on looking. Oh, by the way, the attenuation doesn't seem to work either. The only thing that happens is when I set it on high attenuation, well, it seems to affect the output signal, but in a very weird manner. The fine attenuation seems to affect it even more, but what the hell it's doing, I'll be damned if I know. It seems like it's a modulated signal of some sort that it's outputting, but well, like I said, it's totally weird. I don't know what's going on, so well, yeah, give me some time to check it out, and I'll be back with a update. So stay tuned, guys.